Is it possible that Dr. Rogan here is right and we are actually doing just fine?
No. There is some interesting context to how this has been misinterpreted. It comes from a really interesting study to do with kind of looking at the long-term history of a geological timescales of how climate has varied. But if you zoom in on the actual last couple of million years, and particularly actually if you're looking at the last few thousand years, we are definitely warming, and we're warming at a rate which is really rapid, kind of more rapid than anything we've really seen in the geological record. Just this past couple of years, so in 2023, there was a big warming spike. And then 2024 was the first year where it was above 1.5 degrees for the first time, probably in hundreds of thousands of years. So in that context, we are definitely warming up right now. And it's actually really important that it's to do with the rate. It's the rate of change, which is the issue. If it was going slower, if it was just kind of like the gradual change of temperatures that we see over geological timescales, we could probably adapt to that. But the real problem is that it's going too fast. We're already not adapting to the level of climate change we've seen even just over the past couple of decades.
Dr. David Armstrong McKay is a climate biosphere scientist, communicator, and advocate working to understand and enhance Earth system and socio-ecological resilience for an age of climate and ecological crisis, currently with the University of Exeter, if I'm not mistaken. David, welcome to the program.
Yep, thank you very much for having me on. And at the moment, I'm now at the University of Sussex, as well as being an associate at Exeter.
Oh, okay. So I didn't completely fuck it up. All right, good to know. I apologize for having to open our conversation with this, but it's literally been the stuff of many headlines recently, and it's got to do with podcaster Joe Rogan, somewhat of a scientist himself, apparently, who has in the last couple of months repeatedly and confidently stated that Earth is in fact cooling down,
Oh,
citing an
really?
article from the Washington, yes, really, citing an article from the Washington Post, I'm sure you're familiar with it, that featured a study tracking the Earth's climate in the past, I believe, 485 million years. So here comes my bombshell of a question. Is it possible that Dr. Rogan here is right and we are actually doing just fine?
No. There is some interesting context to how this has been misinterpreted. It comes from a really interesting study to do with kind of looking at the long-term history of a geological timescales of how climate has varied. And it is true that on really long timescales, Earth is in a relatively cool state. It's what we call in paleoclimate science, which is where I did a lot of my training. It's what we call an icehouse state because there are ice sheets at both poles. And that's sort of somewhat unusual if you go back 500 million years. Earth is more often a bit warmer and with less ice. But if you zoom in on the actual last couple of million years, and particularly actually if you're looking at the last few thousand years, we are definitely warming. And we're warming at a rate which is really rapid, kind of more rapid than anything we've really seen in the geological record. Just this past couple of years, so in 2023, there was a big warming spike. And then 2024 was the first year where it was above 1.5 degrees for the first time, probably in hundreds of thousands of years. So in that context, we are definitely warming up right now. And it's actually really important that it's to do with the rate. It's the rate of change, which is the issue. If it was going slower, if it was just kind of like the gradual change of temperatures that we see over geological timescales, we could probably adapt to that. But the real problem is that it's going too fast. We're already not adapting to the level of climate change we've seen even just over the past couple of decades.
Devil's advocate, I totally find this whole argument, quote unquote, horrifying. But like you said at the beginning, there were periods when there were no ice sheets and the earth was still here, plants were still here, I presume animals were still here. So what's the problem?
Yeah. So the problem is it's to do with us being able to adapt to it, and also all the other life forms as well. We live on a planet now where everything is adapted to having ice sheets at the poles, to the level of temperatures we expect, to the rainfall we expect. Some of those past time periods were radically different. And if you just plot everything that lives now, if you plot all humans, their cities, infrastructure and stuff, and all of the animals and plants we have now, if you just put it straight into a warmer planet, like a hothouse state from tens, hundreds of millions of years ago, everything would be screwed. It's that kind of, it's the what we're adapted to, the level of change, the rate of change, that is the issue. And sure, we could get to a state where you lose a lot of the ice sheets at the poles, everything has to migrate, and the life will carry on. But there could be a lot of extinctions, and a lot of the things that go extinct are the things we rely upon. We're far more reliant upon nature than we often tend to think in the modern age. We still have to eat food. We still grow, trees for timber. We're still very reliant on rainfall, of course. All these things we're dependent on, and we're adapted to where they are at the moment. And if they change rapidly, things start to fall apart quite quickly.
You're telling me that climate change actually exists. Is that what you're saying?
That is true. There is, of course, natural climate change.
I knew there was something you're trying to tell me.
Yeah,
I'm very smart.
History, it does happen. What we're doing now is that we're turbocharging it. We're making it much faster, and it's heading in a direction that humans haven't experienced ever before. If you go past 1.5 degrees, you're really going to levels that we haven't seen for the last 3 million years, and that is, that's a long time. That's something that modern humans or any type of human species haven't really seen before. And that will be a new reality we have to live with and adapt to.
All right, now that we've sorted this minor issue, the follow-up question has to be, how bad is our current predicament right now here in 2025? And the reason I'm asking is that when you start snooping around for answers, like I did, I noticed they kind of depend a little bit on who you ask. Some people are saying our situation is completely hopeless and that we should all pretty much start doom prepping, while others, people like data scientists, most famously Hannah Ricci, recently seem cautiously optimistic that we can turn this around. One thing is pretty certain, though. I believe we will breach the 1.5 degrees Celsius limit within a couple of years, which can be really good. On the other hand, my understanding is that the current trajectory of warming, of kind of limited mitigation, will make us avoid the worst case scenario, kind of expanded coal use, I believe, which would entail an absolutely cataclysmic 4 degrees of warming above pre-industrial levels by 2100. So where are we actually?
So at the moment, and there's actually, it's quite difficult to measure the temperature of a whole planet. So there's a little bit of disagreement as to exactly where current warming levels are, especially if you're trying to think about in terms of where kind of like the average, the long-term average is, because that's what's actually important. That's what the the Paris Agreement, all these climate treaties are to do with this long-term average.
Right. So like 1 year of crossing this threshold of 1.5 degrees Celsius, that doesn't really mean anything because it's just 1 year, right?
It's just 1 year, but it means that we're getting close. And the best estimate at the moment for how much the long-term average is we're probably around 1.4 degrees of warming.
Wow, that's pretty close. I thought it was 1.2.
Yeah, it was only like a couple of years ago. It's this recent warming spike has really kind of like accelerated the schedule a bit.
Oh,
and
wow.
It doesn't mean that we're at 1.5, having 1 year above it. But it's kind of like it's, we're so long above that. If you count the number of months above 1.5 degrees, it's sort of difficult to get that unless you're getting quite close to that limit. So we're probably going to see 1.5 degrees, that sort of long-term average, probably around 2030, give or take a few years. It's hard to be exactly
like 4
sure.
years.
Yeah, exactly. And it's because there's all this, we are pushing the average up over the long term, but there's sort of natural variability on top of that. So some years are a bit warmer, some years are a bit cooler. There's some kind of like noise in the system, which makes it difficult to say precisely when we're going to hit it. But basically, within a few years, we are probably going to see 1.5 being passed. How much further we get from there, that depends on emissions. That depends on what we do in terms of climate policy at the global level. At the moment, we're on a trajectory towards around about 2.7 degrees by 2100. That's with current policies that are actually in place. And I should actually say as well, that's 2.7 is the best estimate, but because we're not 100% sure how sensitive the climate system is to CO2, there's a bit of uncertainty there. We could actually see anywhere between 2.2 and 3.4 degrees of warming for that trajectory. So that's kind of like, there's quite a big range around it. We could, if we're lucky, maybe with current policies, it could only be 2.2, which would be pretty bad, but it's not as bad as 3.4, which is equally likely. And that would actually be quite difficult. That would be, It's hard to say what exactly catastrophic warming means, what the word catastrophic means. But I don't think that will be an easy thing to adapt to by any means at all. And you mentioned that some of the worst case scenarios have been ruled out. And that is true, that some of the scenarios I used when we're doing climate modeling, there's one that's been called RCP 8.5 and the sort of technical jargon of climate modeling. And that did just sort of assume that we would burn all fossil fuels. And that would have led to something like, you're right, something like 4 or 5 degrees, which would have been, very much a catastrophic outcome. And that has been avoided. That's good. But that doesn't mean that 2.7 is good to end up at either. And that's because we have what we call a kind of non-linear acceleration in climate impacts. It's not that, every fraction of a degree more is just the same fraction worse in terms of impacts. Every fraction you get more than what we have now from beyond 1.5, every fraction is a bit worse than the last fraction. It accelerates in terms of how bad it gets. So, going to 3 degrees, say, is not twice as bad as 1.5. It would be a lot worse than 1.5 is. Even 2 degrees, when we're sort of comparing 1.5 and 2 degrees, there is a big difference between those. Life is kind of, we would be able to adapt moderately well at 1.5 degrees if we got our shit sorted out. But 2 degrees, beyond 2 degrees, the IPCC says basically it's difficult to adapt to that. Beyond that, it kind of gets tricky to do, to change our current way of life to fit that level of warming.
By the way, the 1.5 degrees Celsius that was kind of agreed upon in the Paris Accord, that's pretty much dead in the water, right? We can't make that.
Yeah, unless
in 4 years, come on.
Yeah, unless something very dramatic happens, then
like aliens come and just they give us
asteroids, nuclear war, something like that.
Okay.
You can't rule those things
stuff.
out.
Yeah.
Basically, we are going to get to 1.5. The question is how much further we go beyond it, and also now there's discussion of overshoot. So if later in the century we might be able to, there's a lot of talk about carbon dioxide removal. So this kind of negative emission technologies, we might be able to start pulling out CO2 from the sky. And also actually nature will do that to some extent as well. Like plants on land and the ocean, they are pulling carbon out of the sky. And they're really helping us. Otherwise, the situation would be a lot worse. Hopefully, the combination of those things might mean that CO2 will fall in the future. And that means that maybe warming will peak and start coming back down a bit, back towards 1.5. That's sort of the good future that we would like to aim for, but we don't actually know how much carbon dioxide can be removed with these technologies because a lot of them haven't been invented yet.
This number 1.5, this is purely a symbolic number, right? Or does it carry any sort of scientific weight?
Yeah, so that's a really interesting point. There's been, again, a lot of discussion over what this means. Originally, it is just from kind of international diplomacy. It's from climate negotiation. Originally, there was this target of 2 degrees, but then a lot of particularly these small island states in the kind of tropical and subtropical island states, they kind of thought this was 2 degrees is unacceptable. That would probably lead to enough sea level rise to see those countries disappear by the end of the century or beyond that. And they didn't want that. So obviously there was a lot of lobbying, and that's where this 1.5 number came in and actually got baked in by Paris Agreement. And that actually took a lot of scientists by surprise. But when we were asked to do a lot of research to kind of look at the difference between 1.5 and 2, and we found, 1.5 is a lot better than 2. You can adapt to 1.5, 2 and beyond is getting pretty difficult. So that's where that came in. But you're right, it's not a solid threshold. It's not like you hit 1.5 and there's a chain reaction and then everything, the whole climate system blows up. There are I do have some colleagues who do try and actually use some of our research to do with tipping points to present 1.5 degrees, kind of reframe it as a physical climate threshold, one that's sort of hardwired into the planetary fabric. But to be honest, I don't really see our research actually really making that case. We have all these big, we'll talk about a bit more about tipping points in a bit, I'm sure. But there are these uncertainty ranges about the thresholds. If you sort of look at it statistically, it's all just to do with every fraction of a degree more makes things, makes it more likely these things happen, makes it more likely you lock in some of these big climate impacts. But there's no kind of like particular level whereas like a massive jump up. So yeah, 1.5 is kind of like it's a line in the sand that the global community, informed by climate science, has drawn to say beyond this, things get too bad, and we need to try and keep behind this line. And if we go beyond this line, we need to try and get back.
If we pull off a miracle and the whole fossil fuel insanity stops immediately somehow, does the planet keep on warming for a while, or does everything just stop immediately after that?
Our best estimate is that after some amount of kind of like there's a little bit of lag in the system, but after around 10 years or so, warming should stop. And overall warming, as soon as if you were to snap fingers and greenhouse gas emissions stop, we would expect, roughly speaking, no extra warming. It just takes a little bit of time to be able to kind of like tell that for sure, given some of that noise in the system. That's assuming we stop emissions right now. And it does make some, this is using climate models, which again have some uncertainty. Some models see a bit of cooling, actually. Some models see a bit of warming. So it kind of depends on, which is better representing reality. But basically, yeah, the overall story is if we stop emissions, we expect warming to stop either soon or pretty soon.
Another interesting thing I've noticed while lurking on social media is a bit of a split between climate scientists themselves. With one camp, people like the eminent James Hansen, one of the pioneers in this field, claiming that the rate of warming is speeding up, and it's speeding up dramatically. The other folks like Professor Michael Mann, equally as eminent, say that the existing models are generally accurate and things are going on according to plan, so to speak. That's a bad phrase. So yes, the planet is warming up rapidly, but the warming isn't wildly abnormal or different from our forecasts. What's your assessment?
Yes, on this, I think both of them have some good points. And I think there is actually just an honest scientific disagreement here that we just haven't quite got enough evidence to kind of like settle it. Generally, Michael Mann is correct that climate models have been remarkably accurate at the global level. If you go back to some of the IPCC reports from around the year 2000, they make some projections using climate models, which at that point were a bit more basic than now. But actually, they do a remarkably good job at projecting warming. We're roughly tracking what they said would happen by this point. If you get into kind of like regional details, it starts to get a bit more kind of because the models are not so good at that level. But globally, they're doing a good job. Equally, actually, what the models show is that on the emission trajectory that we're kind of following, the kind of like middle of the road one, we would actually expect in these climate models some acceleration of warming at the moment. And that's because we're gradually cutting out aerosols. So we're both emitting greenhouse gases that cause warming, but we're also emitting aerosols, which on the whole, they tend to reflect a bit of radiation coming into the...
So that's actually pollution, right?
Yeah, basically air pollution reflects some of the energy coming into the planet. That's masked some amount of warming, something between like a third.
Okay, so let me get this straight. So actually, like, tackling pollution makes the planet warmer. So it's, in this case, not such a desirable outcome.
Yeah, exactly. It's what James Hansen calls the Faustian bargain, that effectively by cleaning up pollution, which is good because it means fewer people die, like millions of people die from this air pollution every year. By cleaning that up, you're actually unmasking some of that warming, which again, globally, that also does cause suffering and kill people. So it's kind of like this difficult trade-off. But in the long run, we know that we do need to stop emitting greenhouse gases because it gets worse, and every fraction of a degree is ever even worse. So it's kind of like we do have to cut these things out, but it does have an unfortunate effect of slightly accelerating warming. And on this question of whether it is accelerating, that Michael Mann is saying, well, we don't really have the evidence for it. Again, that's to do with what I mentioned earlier, to do with there being a certain amount of noise in the climate system. There's some variability, natural variability on top of this like linear or non-linear trend that we're forcing the system with. And that makes it actually kind of hard to tell. Like, it looks like it's accelerating, but if you want to be really sure, if you're doing statistical tests, if you're trying to be kind of like scientific and empirical about it, it can be hard to be sure that that trend is real. You have to kind of, ideally, you wait 100 years and see what happens and go, yeah, that's what the case is. When you're actually in the middle of it, it can be statistically hard to be sure. So that's where some of this disagreement comes from. But basically, climate models are broadly right, but they also do expect some level of acceleration. The level of acceleration that Jim Hansen is projecting is not actually that different from what the IPCC class models are suggesting should be happening. So I think probably there probably is some acceleration going on, but it's kind of too early to be sure.
Theoretically, it is possible
Yeah,
that
yeah,
warming is accelerating, and we won't know until a couple of years from now, at least.
yeah.
Which is a
If you're
little bit scary.
if you're being completely scientifically objective, you'll wait a few decades and write a nice paper about it. But
Which we don't
we are
have.
actually humans
Yeah.
who are alive now. We would like to know. But yeah, I mean, it's understandable as well why people are hesitant about it. In the early 2000s, there was something that was called the kind of global warming hiatus or the global warming pause, where basically kind of like warming kind of plateaued or seemed to plateau for a while. And there was a lot of research about it. A lot of skeptics sort of took it up and said, well, it stopped, so we don't need to worry about things. And then there was a big warming jump because global warming tends to go in steps. It's kind of a bit of a staircase because of this natural variability on top of this long-term trend. And so that's made scientists like Michael Mann and many others hesitant. We were kind of a little bit burned by people overinterpreting that pause or the supposed pause in the early 2000s. So it's kind of like, well, maybe we should be a bit careful about overhyping some of the steps as well. The thing that's really important is that underlying long-term trend, which is only going upwards.
I mentioned doom preppers earlier, and again, scanning through social media, always a pretty unwise idea, by the way. Climate doomism seems to have taken hold, and a lot of people, including a lot of very educated people actually, seem to have just like given up and are urging others to give up any sort of climate action too, making the job of climate change denialists even easier. Why do you think this is happening when we should kind of be fighting the hardest?
Yeah, I mean, this gets into some interesting psychology. I guess there's some interesting politics as well.
But
And
you
also,
must see this, right?
yeah, yeah, and it somewhat relates to my own field of research. So I particularly work on tipping points and feedbacks and stuff like that, where a lot of this sort of fatalistic attitudes tend to kind of like they pick up on it and kind of amplify it. And it's something I do actually push back against because yeah, I've seen a lot of people take research to do with tipping points and be like, well, because a bunch of them have their thresholds, their best estimates around 1.5. That means when we get to 1.5, they all go. They will tip quite quickly, and that triggers some sort of tipping cascade where they trigger some of the other tipping points. That locks in a bunch of warming, and there's nothing more we can do. And that's not actually what our research shows. There's no, although we have those best estimate thresholds for when they're kind of getting likely, that doesn't mean that they all suddenly tip at 1.5. They don't necessarily go quickly. Some of these things take decades. Some of them take centuries or longer to be locked in, especially stuff like ice sheets. Even when you tip those, when they commit them to long-term collapse, they're big and they're slow. They take a while to melt. It's just that you've locked them in. And they don't necessarily lock in a huge amount of warming either. So, like losing the Greenland ice sheet, that's one of the tipping systems we study. That would lock in 7 meters or up to 7 meters of sea level rise, which would obviously be devastating to coastal cities. But it would take 1,000+ years to happen. And it doesn't actually add that much warming to the climate system. So it's kind of like we don't hit 1.5 degrees and suddenly all these things explode and we lock in a much warmer planet. It's much more kind of like as warming goes up, you're making these things more likely. You hit one, you lock in some of these impacts, but you can still prevent extra fractions of warming, and that makes further tipping points less likely. You can't eliminate the chance of them happening, but they become less likely. It's all kind of a more of a probability game where everything's a bit more fuzzy than this sort of like big hard line in the climate system. Everything explodes beyond it. So that's where some of the fatalism has come from, misinterpretation of that. And I do think that some people misuse some of this research as well. So I think some people do take tipping points and kind of to try and make action, kind of make the case for action. There can be a tendency by some to kind of like over-egg it, to kind of like exaggerate it to some extent, make it hyperbolic, be like, well, this worst case scenario, kind of present it as the most likely scenario instead, to try and kind of like get people to act, which is understandable, but I don't think it's not actually that useful, because it scares, maybe it makes some people more likely to act. Other people, it just makes them panic and give up in the way that you're describing. And I think also there's some kind of like odd comfort in that sort of giving up as well. If you take up a fatalistic attitude, it's simple. All of these things I keep on talking about, uncertainties and probabilities, it's all very complicated and very difficult to kind of be certain about anything in the future. And it could be a lot simpler just to go, well, fuck it, I think everything is screwed. That that makes life easier in a way, because it makes it simpler to understand, and it also excuses you from having to do something about it. If everything's kind of more of a middle of the road thing, where it's kind of like things are getting bad, but there's always something you can do about it, but you don't know exactly how bad things are or what's going to happen, that's a much more difficult place to be psychologically. And it also means that really you never get to stop doing stuff. You always have to be kind of trying to think to do something about it.
Yeah, I think you're right. I just saw a short documentary on YouTube about a German guy who just said like, "Oh fuck it, I can't do this anymore," and he bought like a little plot of land and a rifle,
Mm.
and seemed super happy about it, even though he obviously still believes everything is coming to an end, which is kind of ironic.
Some people do go out and do good things and live good lives after that sort of thing, but the main thing is not to spread the idea that it really is kind of like game over, because I also get a lot of people coming to me with quite a lot of psychological distress about this. That, for some people it's a comforting message, for other people it's definitely not. And yeah, I think there just needs to be some level of care around it, and some level of kind of just making sure we are sticking to what we know, but also kind of accepting the things that we don't know and what we're not so certain about, and trying to live with some of those complexities.
Yeah, I think the problem manifests itself. I mean, the biggest problem here, I think, is that when these sort of like collapsologists start collecting acolytes and proselytizing and stuff, turning it into a slight cult.
Mm.
That's where things get a little bit uncomfortable. It's okay if you
Yeah.
decided that, but I think sapping the will of other people to fight climate change is a bit dark.
Yeah, I know there's definitely some odd dynamics that happens in these circles. I'm sort of familiar with some of them. I've interacted with some of these people, and I kind of I empathise with some of the people who get into these things. But also, I know that particularly some of the leaders of these groups, they use a lot of research in a very dodgy way. That
Right.
it just doesn't reflect what we actually know about it, particularly to do with, I've seen a lot of stuff to do with tipping points and Arctic methane and stuff like this, getting really kind of, just being basically wrong. And then being very defensive when we point out, well, actually, that's not, we don't know that, or we know that's not true. And that's, where it gets into some interesting spaces. But overall, I mean, having said all this, I don't want to I don't want to make it sound like we don't need to worry about these things. Like
Of
all the
course.
science we currently have is enough. It's enough to justify really kind of immediate and strong climate action. We don't need any of these hyperbolic scenarios in order to kind of justify doing something. So it's kind of like going further than that is just, it's neither useful or honest, really.
You mentioned tipping points, so kind of like critical thresholds that, when crossed, cause irreversible changes to the climate. Right? Stuff like you already mentioned: ice sheets disintegration, the weakening of the Atlantic meridional overturning circulation, or AMOC, the Amazon forest dieback, and so forth. Now, I heard you say in a recent interview that we are dangerously close to crossing 4 or even 5 of these. Yikes! Now, you said this might not happen. This might happen in like 100 or 1,000 years to be fully locked in. Still, kind of a little bit frightening.
Yeah,
So I'm afraid of you elaborating further, lest I become a doomer myself. But I don't believe they will disappear if we just refuse to talk about them.
yeah. Yeah, so I study these things called tipping points, amongst other things. To define what I'm meaning by this, this is when you get part of the climate system, so say an ice sheet or one of large forests like the Amazon or boreal forest, something like that. And beyond some level of warming or some other thing that's kind of like some pressure, something that's forcing change on them, you cross some level in that beyond which you get a self-sustaining change in that part of the climate system. So there's some warming level where we think you go beyond it, and the ice sheet is committed not only to lose some of its mass, but it completely collapses. And it could be helpful actually to describe how that works a little bit. Ice sheets are actually really, because they're really tall, The Greenland ice sheet is several kilometers tall. The top of it's very cold. It's like going up a mountain. It's very cold as the further you go up into the atmosphere. But as the ice sheet is losing mass in response to global warming, so it's getting the meltwater at its sides, it's kind of flowing outwards and losing height. The top of it is dropping down into warmer air, and that actually helps amplify the amount of melt and the warming over Greenland more than you would have had just from global warming alone. So you get this sort of what we call a positive or an amplifying feedback, making the warming and the ice loss worse. And there's some level beyond which you drop the ice sheet into a low enough part of the atmosphere where even if you were to stop global warming or even potentially to start and reverse it, that meltdown would still carry on because it's now just reached part of the atmosphere where temperatures are high enough that you will just get enough melt to kind of lose the ice sheet. And gradually, after that point, no matter what you do, it will keep on going. It will keep on collapsing. In that case, it would take probably over 1,000 years to happen, but locking in a huge amount of really bad impacts. 7 meters of sea level rise would mean you have to move pretty much all major coastal cities. But there are other ones that could happen much faster. So thinking about the Amazon rainforest, you could get dieback across large parts of that, we think, within a few decades. Or even if we're looking at one part of the particular part of the Atlantic circulation, in some way we call the subpolar gyre, which is kind of like just to the south of Greenland, we reckon that could potentially see convection there collapse within only 10 years. And that would have a pretty much immediate kind of like impacts on across Europe that would be relevant within all of our life spans. So there's the issue with tipping points is this kind of locking in of these serious impacts because you get these self-sustaining changes that we can't easily stop. And it means that even if we were to kind of like do something like global warming, stop it, try and reverse it with magical future technologies, they would just keep on going. And that's the big issue.
Wasn't that the plot of a movie, The Day After Tomorrow? But that kind of happens in a couple of days.
Yeah, so that's an exaggeration of how the AMOC you mentioned, the Atlantic Meridional Overturning Circulation. Our best estimates for that is actually it would happen over the course of decades, maybe 100 years, but it would have really serious implications.
Almost immediately, or in a couple of years.
So what would happen is that you see those changes start to accelerate. So if I go back to the ice sheets as an example, like people could say, well, I don't really care about 7 meters of sea level rise in over 1,000 years time because that's a very long time away. We can adapt to that. But the trouble is that even within the next couple of decades, that could really accelerate sea level rise. By 2100, you could be adding on to you're heading towards adding onto an extra meter of sea level rise, maybe if you look at kind of instabilities in both poles ice sheets. And that really accelerates sea level rise within the time frame we're actually kind of like having to deal with it. If you double the sea level rise rate, that causes a lot of problems in the near term, even if the full implications are far in the future. And it's the same with AMOC collapse as well. You would start to see cooling and drying, actually, importantly. You start to see drying in Europe and shifts in the monsoon belts around the equator. And you would start to see those impacts well before the AMOC has fully collapsed. It will still have an issue, cause an issue much sooner. So we can't just say, well, it takes decades, centuries, we'll just deal with it then. It will cause, again, going back to rates of change, the rate of change would accelerate very soon within the next few decades. The timescale we actually have to be kind of planning things and doing something about it.
But if I understood you correctly, we don't know exactly when.
Yeah, so looking at the temperature thresholds, the statement you were talking about from me, that's to do with our best estimates for some of these systems. So Greenland ice sheet, the West Antarctic ice sheet, like tropical coral reefs, and abrupt fall in permafrost around kind of like the Arctic Circle. Those we had best estimates of around about 1.5 degrees being their kind of tipping threshold. But again, they sit in a wide range. So going back to the Greenland ice sheet, the minimum estimate for tipping threshold for that was 0.8 degrees, which we're well beyond. That happens sometime around year 2000. But the maximum estimate is 3 degrees. So what I'm saying is that even if we stop warming at 1.5 degrees, it could be that tipping in the Greenland ice sheet started a while ago. But because it's such a slow system, we haven't noticed it yet. But it could also be that tipping might not start until well beyond 1.5 degrees. We can't be exactly sure. All we know is that the further we go up warming, the more fractions of warming you add, the more likely it gets. And we were doing a best estimate of saying, well, beyond 1.5 degrees, these things are more likely than not. But we're still, that's still to do with probabilities and chance. And if you add them all up, it doesn't mean that all of them suddenly go at 1.5 degrees. Again, it's just the more warming happens, the more bad things we're risking locking in.
When one of these kind of go, don't they have a domino effect on the others?
Yeah, so there is a potential for what we call a tipping cascade. In general, so some of my colleagues have been doing research on this, and they look at how, because everything in the Earth system, in the climate system, is interacting, and everything is connected to each other. And some of these interactions are stronger than others. And in general, it seems that most of these interactions mean that if you destabilize one tipping system, you tend to destabilize ones that are connected to it. So, for example, the Greenland ice sheet, if you that starts to collapse and accelerates meltwater coming off, which is fresh water coming into the North Atlantic, that can disrupt that Atlantic circulation we're talking about, because that's all to do with how salty and dense the water is there. So, Greenland ice sheet collapse could make AMOC collapse more likely. But there are some converse scenarios where, if for some reason the AMOC were to collapse first, maybe we've misestimated, or maybe it happens at its lower estimate and Greenland ice sheet happens at its upper estimate. AMOC collapse, because that causes cooling in the North Atlantic, that could actually protect and stabilize the Greenland ice sheet. So this is where some of the complexities start coming in and being like, yeah, we could get a domino effect between some parts of it, but it kind of depends on the timing of it. And a lot of models that we have at the moment aren't really set up very well to be able to deal with this. A lot of the Earth system models have come up really leaps and bounds in the last couple of decades, but most of them still don't have, if you have ice sheets melting in a climate model, they don't all have the effect of the meltwater coming off that ice sheet on the ocean around it, because that's really difficult to do. It's really difficult to program that into the model. It's not like an oversight, it's just difficult. And that means it's kind of hard for us to say exactly how some of these interactions work. We think they're destabilizing on the whole. That's, seems pretty likely. But exactly how much, to say this tipping point causes that tipping point, that's still actually quite difficult to say for sure. We can just sort of say, well, probably it's a bad idea. And all of this adds up to, well, that means that we should take precaution and limit warming as low as possible because we know these things are plausible.
Which one of these would have the most dramatic and the most immediate effect on our civilization?
Well, yeah, dramatic and immediate are kind of like opposite poles on this sort of thing. So, like the
I'm not
AMOC
making
collapse,
it easy.
yeah, AMOC collapse would be really dramatic in terms of like parts of Europe be kind of multiple degrees cooler, really dry. There's some studies looking at agriculture, basically in the UK at least, wouldn't be able to grow crops anymore without huge amounts of irrigation because it dries out so much. And it shifts all the monsoon belts. That shifts where a lot of people would have to be living if they're doing rain-fed agriculture. That would, AMOC collapse would really redraw the global map of where people live and can grow food. And similarly, ice sheet collapse, that would redraw the world's coastlines. If you had in the West Antarctic ice sheet as well, up to 10 meters of sea level rise would redraw the global maps. But these things would take, AMOC might take a century. Greenland ice sheet and West Antarctic ice sheet may take thousands or more years. These are quite long-term things. The shorter-term things, the things that could really hit us this century, tend to be somewhat less dramatic, but they could still have really serious consequences. So I mentioned that thing to the subpolar gyre collapse. That's kind of like a mini AMOC in terms of its effects. It's maybe like half as bad, but that could happen within a decade or so. Amazon dieback, a lot of that could happen if it started soon. A lot of that could happen within this century. And that would cause, apart from losing a huge amount of biodiversity, obviously, in terms of direct human impacts, it would cause a lot of extra warming through South America. You would lose a lot of rainfall, both in the kind of the Brazilian Amazon region, but also down further south into the southern cone of South America would lose a lot of rainfall because it's effectively kind of like powers an atmospheric river. And that would happen, a lot quicker than some of these other things. And also there's coral reefs. We're already at the point where we are seeing regional die off of coral reefs, and a lot of people depend on those. Something like 500 million people are dependent in some way in their livelihoods on coral reefs. either for fishing or because of coastal protection or tourism as well. And so that's a lot of people who, within the next couple of decades, their livelihoods might be gone. And 500 million people, that's a lot. So I think it's kind of saying which one is the most dramatic and scary and immediate one is quite difficult to say because we're all kind of horrible in different ways. But probably actually one of the ones I'd be more worried about is Amazon dieback at the moment because it has that combination of it's not just climate change causing it, it's deforestation as well. And in many ways, it's the deforestation which is actually closer to pushing over the edge. And to be honest, just losing large amounts of the Amazon would be just tragic in its own right as well.
Would it also release huge amounts of CO2 into the atmosphere?
Yeah, so it would release quite a bit. There are various numbers floating around as to exactly how much, some of which are a bit off. But in general, we would expect it to be releasing something like the equivalent of 6 or 7 years worth of current human emissions, which would be a lot. That's not really unwelcome. But it's also not kind of like similar with permafrost as well. It would amplify emissions, make the situation worse. It would make it really difficult to keep to climate targets. But overall, human emissions still stay the main dominant driver of warming. It just makes it, that X% worse on top of it.
You mentioned Europe before when you're talking about AMOC. Is it true that Europe is warming up twice as fast as the other continents, and why is that happening?
Yeah, so this is Europe is one of the, I think it might actually be the fastest warming continent, and partly because it's next to the Arctic Circle as well. So it depends. The further north you go, the stronger that effect is. There's this thing called polar amplification, or particular Arctic amplification at the moment, which is a big factor in that. Is as the amount of snow and ice is declining. That's a very reflective surface. It actually reflects a lot of the sunlight, and that means the thermal radiation as well coming in from the sun because it's bright. It reflects a lot off. If you expose much darker ocean, the Arctic Ocean below it, and soils around the kind of Arctic fringe, they absorb a lot more energy. So as you lose snow and ice because of global warming, you're actually getting an amplification of warming in those regions. And so there are parts of the Arctic that are warming 3 or 4 times the global average as well. That means all of the impacts of climate change are that much worse in those regions. And Europe kind of sits at the edge of that. We're getting some of that effect as well. And there's some other aspects on top of that too.
All right, we talked about how bad things are at the moment. Let's turn the page and spend some time discussing possible solutions.
Mm-hmm.
So what do we have to do first in the fight against climate change?
I mean, the big thing I always highlight is that we do have a global agreement that all governments signed up to in the form of the Paris Agreement, which is to keep warming as low as possible.
Bit of a paper tiger, I'm afraid. Yeah.
Well, I mean, it's still impressive that it happened, and it's still something that we can try to hold governments to.
But isn't every COP just like a massive disappointment? There's all these wild expectations year after year, and then they can't even agree on phrasing stamping out fossil fuels into the final text in like 2024. I mean, it's pretty ridiculous.
Yeah, I mean, it took nearly 3 decades for the declarations to include fossil fuels in them. So it's
like phasing out. It's not even. It's they use all these euphemisms.
Yeah, there was a debate over phasing out or phasing down.
Exactly. Yeah.
Like that. Yeah, I'm not a huge fan of the COP process. Although one thing that is important about it is that it is one of the few forums in which every country in the world gets an equal sitting, equal table, or roughly equal. There's a lot of issues to do with some nations having bigger lobbying power. There's a lot of lobbyists there as well, but it is still
apparently there's more fossil fuel lobbyists than actual state representatives.
Yeah, so
fuck's sake.
As a fora, it's like really flawed. But it at least exists, and that is something in its defense. Of like, it is some sort of global democratic forum.
The cup is half full. Yes.
Yeah, but yeah, countries, states, corporations, they're not doing enough. I was talking about on track for 2.7 degrees at the moment. There's a certain amount of backsliding. We're not kind of like advancing right now, and the target of keeping the Paris Agreement wanted to keep. The main thing is to well below 2 degrees, aiming for 1.5. Well, aiming for 1.5, probably can't happen now unless we overshoot and get back to it by the end of the century. well below 2 degrees. It's a bit of a fuzzy thing, but that's still actually possible if there are rapid emission cuts. And the state's action around the Paris Agreement is obviously kind of underwhelming, but it does actually give us a tool that's kind of like citizens and movements of people to hold them to it, because they did sign this thing. They did all state, yes, climate change is very serious and we need to do something about it, and these are the goals. And to some extent, we can hold them to account for their failures. That's the kind of remaining power of Paris Agreement and 1.5 and well below 2, is that we can hold them to account for their failures. And also, some of the global South countries can be like, well, you promised to do these things and you didn't, so now you owe us some loss and damage, because we're at the front line of facing some of these climate impacts that are reducing, causing suffering in our countries, reducing economic growth, things like this. So in terms of what we need to do about it, obviously it just always continues to be cut greenhouse gas emissions as fast as possible. That's primarily fossil fuels, just phasing. Some of the debate around phasing out, but getting rid of fossil fuel emissions as soon as possible is the main thing. There also needs to be transformations to how we grow and eat food. There's a lot of food being wasted. There's a lot of forests being cut down for it. There's issues to do with kind of like methane emissions as well from cattle. There needs to be a transformation in the food system as well. But the main thing just remains eliminating fossil fuels as quickly as possible. That has to be the thing. And it just has to be something we just keep on plugging away at. Obviously, politicians are not doing enough. To some extent, I have to take my scientist hat off here and speak as a citizen. But politicians, I don't think, are doing enough of this. And it's the job of citizens and political movements to hold them to account, to push on that, to try and do as much as possible. And something else that could help is that, particularly at Exeter, a lot of my colleagues there, they focus on something called positive tipping points. This idea that because there are tipping points in the climate system, we know there are some of these dynamics there in physical, natural systems. There's also some evidence for them being in social systems as well. Often they are negative. They can be things that are bad transitions. But there's this idea that maybe there are positive ones, or things that we think are positive, where we can so an example might be solar power becoming really cheap. That at some threshold, it basically became so cheap that even if you took away all the subsidies from it, it would just continue to grow and dominate the energy system. There's been there's some more debate around it, because social tipping dynamics are a lot messier. People have agency. Even if there's some sort of solar power tipping point going on, you could get a government coming in, for example, that just makes laws against it. We've seen some of the stuff in the US at the moment to do with basically trying to stop all wind power development because of arbitrary reasons. Social tipping dynamics are messier and maybe kind of a bit more kind of uncertain than the physical side. But that is something that, maybe we could try and accelerate things in a way that, they start becoming self-sustaining in terms of, the things we want to see. Kind of the transformations within society and economics, maybe some of those could start going really quickly as well, and that could help reach the sort of pace we need.
Yeah, it's one thing for the states at COP or whatever to write and sign a document, but it's another thing to implement what they're saying, because we see it totally didn't happen with the Paris Accords. And apparently you can just withdraw from the Paris Accords after you've already signed it, which America has done twice now.
Yeah.
And you mentioned the current administration, who doesn't even believe in climate change. And I believe the motto is drill, baby, drill, which is just,
and it's been
nightmare.
There's rollbacks, not, obviously it's most dramatic in the US at the moment. But, sitting here in the UK, the previous party of government, the Conservatives, have basically just abandoned a lot of the sort of previous kind of cross-party consensus on doing something. And across, a lot of countries, there's a bit of a rollback going on. And that's where I think, it really comes down to people and movements to try and hold them to account. We can't just expect states and corporations to sort of stick to the pledges they've made and the treaties they've signed without there being pressure as well. Because, obviously a lot of them are going back on their word, and that means that people have to push back on it as much as possible.
You said that the number one thing is obviously that we need to reduce and eliminate fossil fuel emissions. Globally speaking, is anything happening there? Is there any sort of noticeable reductions,
Yeah,
or
so
not really?
fossil fuel
Have we
emissions,
have we reached the peak yet?
not quite yet. It's slowing down, but every year there is a little bit more. There's something called the Global Carbon Budget, which is actually
For God's
published
sake!
at the
Yeah.
sidelines of COP every year. And never know. Maybe this year there has been a peak, but probably not. But it's kind of like the increase every year has been slowing down. It's sort of heading towards plateauing. But the trouble is that even if we just plateau fossil fuel emissions for the next few decades,
They're still
that's still
horrible.
that's
Yeah.
still heading towards that 2.7 degrees future. Basically, is predicated on that. We need it to peak and start falling quite rapidly, and that's we haven't seen that happen in the data yet. We have seen, the counterpoint to that is that there is a huge boom in the amount of solar power being installed. It's sort of a running kind of joke in renewable energy circles of kind of like looking at the projections that various global institutions make every year of how they think solar power, wind power, whatever is going to do over the next few decades. And every single year they've been wrong. They always underestimate the acceleration in solar power. So that's kind of like the positive thing. That's the sort of thing that you mentioned Hannah Ritchie earlier, Our World in Data. That's the sort of thing that they highlight, being like, well, there is this huge boom in solar power, and that is good. It's just at the moment we are continuing to see fossil fuel emissions growing at the same time as renewable energies. So we need to get to the point where the latter is starting to eat into the former rather than just adding on. And that can happen. It's not a case of it's impossible to stop growing fossil fuels. It's just not there yet. And that's what we need to push on. And it's to do with actually kind of like trying to legally limit fossil fuel development as well as one proposal. And there's also stuff to do with sufficiency, that it will be a lot easier to completely replace global energy with renewable energy if we're not using quite as much, and if the amount we're using isn't constantly growing at a huge rate. If there's some level of sufficiency going on in there as well, of trying to just be more efficient, maybe some things we don't need, then that makes it easier to replace it all with renewable energy.
With the advent of AI and these huge data centers being built left and right now, it doesn't seem like it's going to go that way, but hopefully I'm wrong.
Yeah, I mean that the AI definitely doesn't help. I mean that there's a lot that can be said on that technology, which would take a whole other podcast to do. There are some things which are useful from it to do with machine learning. If you actually disaggregate it into how it works and the different types, machine learning could be useful for climate science. It could be useful some of the energy transition stuff. But in general, a lot of the stuff that's particularly to do with kind of like just these huge data centers going up to power chatbots that can't really tell the difference between truth and lies. And some of the big ones that the ones that are built for Grok in Texas, where they had to install loads of gas burning turbines all around it, which are kind of like air polluting surrounding communities, just to power Grok, which is not that useful a thing. So all those things are not helping the energy transition. But we just have to keep on pushing on it, and maybe a lot of that stuff is a big bubble and will be falling away in the next few years. You never know.
Oh, from your mouth to God's ears, as we say back home in Slovenia. The new shiny toy in the possible solutions department seems to be geo-engineering, so some sort of a techno fix, like whitening the Arctic ice to reflect the sunlight back into space, or injecting aerosols, we talked about aerosols before, into the atmosphere again, which would supposedly have a similar effect. So, but however, a lot of smart people are saying this kind of tampering with the climate could have unforeseen and potentially dangerous consequences. What's your take here?
Yeah, so this is a complicated one, and especially because I know people who take strong positions across both sides on this one as well, including some there are a lot of climate scientists who I think have justifiable concerns about it, given that we don't really fully understand how the climate system works. Our climate models are not, they've improved a lot, but they're still not great in many things. I mentioned the stuff to do with a lot of interactions between different parts of the climate are missing. And that makes it quite hard to actually project how well it could work. In theory, if you take a model, you do, say the stratospheric aerosol injection method you just mentioned, you can limit global warming in them. It has some potential issues to do with changing where precipitation is. So rainfall, it kind of changes rainfall patterns around the world in ways that maybe countries that suddenly get less rainfall would not like. And none of these things can recreate past climate. You're effectively engineering a new, different climate. There's no going back. But in theory, you can halt global warming or reduce it, and that could, in theory, prevent some of these tipping points. But where it gets complicated and messy is to do with what I mentioned, to do with the thresholds being uncertain. We don't know exactly when these tipping points are going to happen. And also some of the stuff to do with in these models where you can't try and prevent a specific tipping point. So, for example, the West Antarctic ice sheet or something like that. What you might do in terms of geoengineering to prevent one tipping point might make another one more likely. And especially because our models are kind of limited, particularly actually limited in terms of stuff to do with rainfall. The whole water cycle side of things is a lot more uncertain. A lot of models disagree on that. You don't want to be in a situation where, to try and prevent ice sheets tipping, you accidentally dry out half of the Amazon rainforest, because that's it's difficult to try and optimize things for everything, and particularly if you throw in kind of all the political stuff as well. On the other hand, I do understand where geoengineering researchers are coming from. I do know some of them, and they are coming at this in good faith. They do think it's kind of like they see there are risks and problems with geoengineering, but they sort of think it's worthwhile researching it just in case. And it's a case of kind of the case they present is to do with kind of like a risk trade-off. It's kind of like we can't just look at the risks of geoengineering in isolation, because we also have the risks of unabated climate change as well. And it's kind of, you have to trade off the risks of further warming versus the risks of geoengineering. And that becomes a lot more difficult to do, and they advocate doing further research on it. Personally, I am skeptical of both the technological and especially the political feasibility of these things. On the technological side, the aerosol injection is probably the most likely to work, but even that requires fleets of planes running constantly for decades, which it would be a big, expensive operation.
For decades. Wow.
Yeah.
So I thought it's just like a one big cannon and they're just shooting
it has to carry
then we're
on.
done.
Yeah, and this is the issue that if you did it in a situation of, we did nothing about emissions, they just kept on growing, but you also did geoengineering, they would be gradually masking more and more warming. And if for some reason that program stopped because of geopolitical tension or wars or something like that, you would suddenly unmask a lot of warming, and that could be much more catastrophic than just having done it anyway. That's something called termination shock. The counter to that is, well, we would only do it on kind of like sensible ways of, we have a bit of overshoot over 1.5. We just use geoengineering to kind of mask, kind of shave off. They call it peak shaving. So you keep the world at 1.5 degrees whilst you're inventing the negative emission technologies to do that overshoot. And then you stop doing geoengineering when you've removed some of those emissions. The trouble is that still means doing it for decades. And a big question with all of these sort of things: who's going to pay for it? How do we get in a world where we have geopolitical tensions and fragmentation already, that we can't even agree to do something about climate change?
I have an easy solution for that. How about billionaires? Apparently, one billionaire has the carbon footprint of 1 million average citizens. I've read somewhere.
Yeah, I mean that's. There is discussion of it being kind of like a unilateral thing, that a big corporation or a very rich philanthropist could just go ahead and do it. But the trouble is depending on how you do it, it really could have, it's all the trade-offs to do with like, okay, you do that to reduce global warming, but it's not an even reduction of global warming, and it changes rainfall patterns as well. So what do you do, if thinking if states unilaterally do it as well? What if China does it? But the way it happens, it kind of like screws up the Indian summer monsoon. What's India going to say about that? What are they going to do about it? It's all these kind of like geopolitical trade-offs that make it kind of like, if we thought trying to stop emissions was difficult at the global diplomatic level, then doing sensible geoengineering would be very difficult as well. Not impossible, but I struggle to see it within current political circumstances. And that's for something that's the more technologically feasible. We have planes, we can probably do some sort of spraying thing on them and have that within some level of years. But some of the other things, like to do with, you mentioned whitening the Arctic, a lot of those things, the technology is just sort of a bit goofy, to be honest. Of kind of like, oh yeah, we'll just spread glass beads over the entire Arctic. Like, spread what? And then having little windmills that pump water up onto the sea ice to thicken the sea ice, and each one can cover a few football pitches worth or something like that. But the Arctic Ocean is really big, and it's really difficult to work in and get to. Like, spreading millions of these things across the Arctic would be not a minor thing. And I sort of struggle to see how that's likely to be feasible. And again, who pays for it? It's difficult to get anyone to pay for anything, even if there's a clear benefit to doing so. So who's going to pay for all these things unless there's some sort of global ordered, carbon market or something like that? But even that has had its issues. So yeah, in general, I understand why people are researching it. I can see the points being made on it. There's the difficulties of trading off one risk against the other. But in general, I just remain a bit skeptical at the moment of it being feasible in the current situation we have.
Climate change is just like one of the issues that that our civilization is currently facing. There's deforestation, like you said, there's loss of biodiversity, microplastics. How are we doing on these other fronts? How are we doing holistically on the whole environmental department? Because even if we fix climate change, there's other dangers.
Yeah,
there's lots of talks of like treaties, like the ocean treaty, the plastics treaty totally fell through. But like a lot of countries have reforestation programs and so forth. But it's kind of, I don't know, impossible to find out how we're doing globally on tackling these issues.
Yeah, I mean, it's one of those things that there are some good things at local scales that are worth sort of looking at and celebrating. But on the global scale, similar to climate, possibly even less good than some of the global climate progress. Okay. So there's been a bunch of biodiversity treaties. There was one signed in Aichi a number of years ago. They set a number of targets. I'm pretty sure it was that all of those targets were missed on biodiversity. There is new stuff to do with kind of protecting 30% of the biosphere by 2030, sort of 30 by 30. But again, stuff on that is really slow. A lot of countries are not really, they're promising, states are promising to protect things, and either they're just not doing it, or they're putting in paper protections, just declaring somewhere a national reserve, a nature reserve, and not actually doing anything on the ground there. And then you noted there the Global Plastics Treaty. On the pollution side of things, there are global pollution treaties, and we have to celebrate some of those. Particularly the Montreal Protocol, which is what stopped the emission of CFCs back in that was signed in the late 1980s, and that's to do with the ozone hole. And the ozone hole has gradually been mending. It's still not fixed yet. There are still some places that are doing sort of sneaky emissions of CFCs, but actually, on the whole, that was a problem that was spotted, negotiated, and to some degree dealt with. So that's something, on pollution front, that was a good thing. And of air pollution, we mentioned before, that is being cleaned up. That's good too, with the trade-off of it making global warming a bit worse as well. So we have to, those things we have to celebrate. We also have to celebrate where there's been great work on the ground to do with kind of protecting biodiversity. But at the global scale, there are a number of those things that are like climate change. There's a lot of talk, but not enough action. And we do have to remember to push on those as well. And that's something that, with tipping points, particularly I was involved in the Global Tipping Points report, where we do look beyond just warming as well. Warming is one of, climate change, global warming is one of the main drivers of these things. But there are, the Amazon has deforestation. If you look at things like coral reefs or mangroves, there's pollution as well, just direct habitat loss. We have to consider all these things if we want to, make sure we deal with all these issues at the same time.
In the end, let us circle back to our friend fellow scientist Joe Rogan and the issue of climate denialism. Whenever there's like a bit of news on the deteriorating state of the climate, the comments underneath the article seem to be full of like hateful spite, usually to the tune of something like, oh yes, I'm sure another tax will fix this. Even Joe Rogan said climate change is just a big money-making scheme, neglecting, of course, the actual money-making scheme that has been going on for the past 80 years, which is the fossil fuel industry. And yet we can all observe pretty much with our naked eyes now, or maybe just those of us who are a bit older, that the normal weather of our childhoods is pretty much irreversibly gone. Every summer seems a bit crazier than the previous one. Like with all breaking records, floods, wildfires all over the place. How do they say this is the coldest summer of the rest of your lives? A bit dramatically, but probably they're right. It's just going to go downhill from here if we don't act on it dramatically. But still, it isn't enough to convince a lot of people out there. Why do you think climate denialists exist in 2025? And what's the best way to make them kind of see sense on this issue?
Yeah, I think this is this is sort of getting a bit away from my own research area, so to some extent I have to
But you must deal with it a lot.
Yeah,
right?
yeah,
it must infuriate you that you dedicated your life to this research and there's still people who just don't believe in it. Like, they just say, no, the sky's not blue, it's green.
Yeah, it's taking off my scientist hat and sort of, thinking more kind of like as a person and thinking about some of the stuff I've seen, the experiences I've had talking to these people. It's a lot to do with worldview. It actually gets into, I think, stuff around science communication as well. There is kind of an assumption that if we just show people facts, then you do that enough and it changes people's mind. We assume that people are just kind of like, the reason they oppose stuff is because they just don't know. They don't know enough about it. And that's something that we call the information deficit model. It kind of relates to how we think about learning as well, that people are just kind of like empty vessels and you just have to fill them up with facts and they do the right thing. And there's been a lot of research to show that's not really how people work. People have worldviews. They understand and learn things through stories and narratives. And that's a powerful thing. If you have a worldview and a narrative that this, climate change or similar issues doesn't fit into, then no amount of facts being spewed at you by well-meaning science communicators is going to really get in. That's not to say that science communication doesn't need to happen. We do obviously need to be getting facts out there, but we have to understand that people aren't necessarily going to pick them up unless they're somehow made relevant. And that's where people who kind of think about talking about stories and narratives, ways of fitting in with the way that these people have their worldviews. That there's been work by an organization here in the UK called Climate Outreach, where they have a package of kind of ways of talking about climate change that fit with centre-right voters or religious voters or things like that. Ways of talking to people with different worldviews that don't immediately switch them off. And that's not necessarily showing them a different set of facts. That's just knowing how people tick and how people understand things and how people learn. And that's kind of, I think that's the main issue. That it's to do with people don't just pick up facts and do something about them. And that's something that, maybe people on climate action have kind of underestimated the degree to which people don't just respond to science. Science is a necessary but insufficient condition for action on climate change. We need to have the science to tell us what the issues are and kind of sketch it out, but it's also to do with people needing a vision of the future, something that's desirable, something that connects to their local small day-to-day struggles with the bigger picture, that crosses that divide and goes, well, this is something that will make your life better. And also it's worth pointing out as well that there is a huge political machine against this as well. There's a lot of people who have made a lot of money off of fossil fuels, and they have been putting out bad faith attacks for decades. Like, I'm pretty sure some of the skeptics you've been mentioning, I'm pretty sure a lot of them don't actually believe what they're saying. In the UK, a minor example is a guy called Jeremy Clarkson, who he spent years
the car guy.
Yeah, the car guy. And when I was growing up at school, a lot of people quoting him on climate change. He had a climate skeptic position, and then decades later he was like, "Oh, I didn't believe that. That was just part of my character. It's part of the act." People know not to believe that, but I saw in my own eyes the influence that had. And so, yeah, I think a lot of this is coming across in bad faith when people say these things aren't true. And there's a lot of money and a lot of power. And that's where it gets beyond science. Science can tell us some stuff, but you can't expect science to do the work of challenging some of these powerful interests. That goes beyond science into political movements and activism and things like that that are needed to deal with it.
Yeah, it does. It's strange, but it seems that in conservative circles, acknowledging climate change is kind of synonymous with some sort of a devious Stalinist plot, when in reality it's just science. Why do you think that is? Because we need everybody on board for this, right?
Yeah, and I think it's to do with worldview. It just doesn't fit into it. Whereas some of the same people who deny climate change as actually happening, they're quite happy to go and believe in that geo-engineering and weather control and modification is already happening. And there's all these bills, especially in some of the Republican states in the US, where they're banning geo-engineering on the assumption that it's already happening and that all the strange weather things are actually to do with there's an evil conspiracy to control the weather. But the thing is that's what we're saying. There has been a conspiracy to hide the fact that burning fossil fuels has changed the weather, and it's very difficult to get your mind around sometimes how someone can not believe in one form of climate change because of conspiracy, but invent an entirely different fake type of climate change with a conspiracy behind it. And it's to do with worldviews. They just have a worldview where that makes sense, and then you cherry pick the facts to fit in with it. And unless we start kind of dealing with that, that's how people work in the world. That's how people understand the world. That's how people do politics. Yeah, that's just going to keep on happening.
I do have a minor gripe. I wrote to many climate scientists, and it's really hard to, present company excluded, of course, because you politely answered my invitation. But I know you guys are busy, but it is hard to get a lot of you on a podcast, I have to say. I didn't have this problem with like astrophysicists and consciousness researchers and stuff like this. And then in their place, of course, some sort of a wacky but loud climate denialist is going to appear on Joe Rogan. Of course, this is like a really small podcast, but I'm speaking in general. I don't see many notable climate scientists appearing on these big podcasts on the new media and trying to reach out to new audiences like the other side is doing. Perhaps a bit of a problem.
Yeah, no, that's an interesting one, because there definitely are some people who do engage with that stuff. But I think also there is a reticence because we've historically had to be very careful. There are, I would go back to the powerful interests. There've been powerful interests who have been undermining and forget the word for it, but there have been forces that have been trying to make climate scientists look bad, like they're liars, that they're that encourage kind of like attacks on people's kind of positions. And it makes scientists quite reticent. And that's one of the reasons why we tend to stick with the IPCC so much, is that it's such a sort of big, robust, solid process that it kind of, it's we don't want to go beyond what we can say about things, lest it be sort of taken up in bad faith by people and misused. So there is kind of like an understandable reticence there. I'm not so familiar with the podcast space as to why people aren't necessarily taking it up there. But yeah, I do think it is important for scientists to be getting out there and having dialogues. That is an important part, I think, of science communication. But I guess we're just a little bit, it needs to be good faith dialogues. Like, I'm not sure to what extent going on Joe Rogan to debate him. I personally wouldn't want to do that because I just wouldn't enjoy it. But I know some other science communicators have done that. So in archaeology is quite a different example. There's been a lot of debate to do with pseudo-archaeology and people making up weird
Graham
stuff. Hancock. There's a guy called Flint Dibble. He did go
Flint
on
Dibble.
I'm
Team Flint. Flint. All the way.
That was
baby.
Great. But to be honest, I wouldn't be that keen to do that myself. It doesn't sound like much fun. It takes a certain character to be able to do that and enjoy it. And hold your own. Whereas this is nice. This is a nice, proper, good faith dialogue about stuff, and I think that's good. I think ideally more scientists would be doing that sort of thing and talking in different venues that aren't just appearing on the evening news and giving a 30-second soundbite on the new paper. I think it's good to be talking like this, and even going out and talking to something we did during this climate strikes that are happening on Fridays for a few years. We went out and talked to them. We had a stall that these climate strikers could come and ask us on the street and have a dialogue, a conversation with a climate scientist about their worries and their concerns and their questions. And I think that was really important.
Yeah, and also I think it's a good idea to break it down, because us normal people, we're not going to read the IPCC report. That's just not
it's
all
too
that
much
much
for
fun.
us to
So
read.
so you need somebody to tell you, what does 1.5 degrees mean? What does 2.7 degrees look like? Like, where are we right now? Where are we going, etc. Anyway, I wanted to ask you this. Last year, The Guardian asked 380 top climate scientists what they felt about the future, and the answers pretty much ranged from hopeless to broken, and I'm quoting here. Not exactly like a viewing of a light-hearted Seinfeld episode, that. Do you have hope for the future?
Now, this gets into an interesting differentiation between hope and optimism. I wouldn't say I'm optimistic about the future. Defining optimism to mean the expectation that things will turn out well. I would probably tend to be like some of those scientists. They're asking them what kind of average level of warming they're expecting by the end of the century, and actually they pretty much landed on the current projections of around somewhere between 2.5 and 3 degrees, with some people thinking a bit higher and lower. It actually matched the kind of the distribution of the current projections given current policy. So basically, like them, I'm somewhat pessimistic about a rapid strengthening of action on what we currently have. But there's a difference between optimism and hope. Hope is carrying, even in very kind of like dark situations where nothing seems to be, even when you feel despair, hope is when you think you maintain that it is possible for things to be better. It is possible for the good thing to happen. It is possible that there could be rapid action, or that even if we miss some of these targets we have, these limits we have, that even in that case, it will still be worthwhile doing something the best we can. And that's a hopeful position. It's sort of like people talk about critical hope being a thing. It's kind of like you're not expecting the good thing to happen, but you're maintaining that it is possible, even if it takes a long way to get there, and it's not the ideal way of getting there either. So yeah, I guess I would say that I maintain hope, even though I do sometimes feel despair. And I think there's a lot of people who do feel like that as well. And I think that's sort of quite a reasonable position.
My hope is with young people. They seem pretty cool. Maybe they'll manage to do better. But
yeah,
I was just thinking about
my hopes in people coming together. It has to be to do with people, grassroots action from the bottom up that holds these power structures to account, because clearly they're not doing it on their own, and that's where I would tend to put my hope as well.
When we were discussing the IPCC reports and climate science communication and podcasts and so forth, I said, things are too vague for most people right now. So you said we're currently headed to between 2.5 and 3 degrees of warming.
So by the end of the century, 2100.
Right. So what does the world, if we're being a bit in more plastic terms, what does the world or our civilization in that scenario actually look like, so we don't leave it on these kind of more like abstract terms?
Well, I might end up being a bit abstract here as well, because we don't exactly know. We don't have models that tell us exactly how the world is going to look like. But we do know that even 2 degrees would be a much worse world than 1.5 degrees. It's well beyond 2 degrees would have far more what we think of currently being climate extremes, like extreme heat waves and droughts and storms and things like that. Those effectively become the norm in those higher warming scenarios. They just become the new reality, and then you get that becomes the average. What is currently extreme is now kind of the standard future. Then you get extremes on top of that. So the extremes and the kind of like higher, heading towards 3-degree world would be something that we haven't even seen before. And it's a world in which I can't see the level of kind of the way of life we currently have being sustained. I mean, arguably it can't be sustained as it currently is, but definitely it will be difficult to have the world as we understand it now, the world as we know it, with countries arranged as they are, with technologies and infrastructures. Pretty much everything would have to be rebuilt. And something we can say from the IPCC is that beyond 2 degrees, adaptation is difficult. You can't just do the same thing you were doing but tweak it a bit to make it work in a new climate. You basically have to do entirely different things. You have to grow new crops. You have to move to new places. You have to rebuild all your infrastructure to cope with new temperature extremes that you didn't have before. Everything would have to be rebuilt. And by that sort of temperature level as well, you are committing probably to a lot of sea level rise. So that's like eventually, gradually cities and would have to be moving from the coast, and farmland around the coast would be gradually less and less viable. It's a world in which everything changes. What we can't say exactly is what that looks like. We can just say that, well, it would probably be bad. We'd rather keep what we have and do what we're doing better than having to do everything completely different.
Yeah, because like we said at the beginning, and like people say often, yeah, but the world was much hotter before, so what's the problem? But they forget to add that there was no people.
Yeah, we weren't there. And also, even just things to do like, animals and plants and stuff moved in response to past climate changes. Now there's like a human civilization in the way. It's not that easy. There's stuff that's fixed. It's hard to rebuild things. It's hard for trees and animals to move with changing climate, with everything the way it is. And that means that basically that sort of world will require a radical transformation in order to make it, it would require a radical transformation either way. Either we radically transform how we do things in order to cope with it the best we can, even though probably it won't be great, or that will be forced upon us and things just start to break down, and all the tendencies that we see in the 21st century will just be amplified and locked in.
I talk to a lot of historians on this podcast, and there's a lot of scenarios when the climate changed locally just a little bit and it caused like a Bronze Age collapse, So yeah, there we have it. Yeah. We're going to end this conversation.
We are more dependent on nature than we think.
Right.
We think we've in the modern age, we feel like we're, there's this big separation between us and nature, but it's still everything. It's still the air we breathe, the water that comes out of the tap, the food that comes in, the stuff we build stuff out of. We're still entirely dependent on nature. And if things become, the world will become very, very different, something we're not familiar with, and that'll be, very, very difficult to deal with. Not impossible, but it's worth trying to avoid it.
Yeah, maybe the changes have to be made on a more fundamental, systemic level there. Because right now, you go to the supermarket and it feels like an episode of Star Trek. The steak just appears there, like that little machine that they have. You're completely removed from the whole process of what went into that steak being there.
Yeah, I think that's systemic changes. We have to transform one way or another. Things are going to be radically transformed. It's just we can either choose to do it ourselves in a way that makes things better for more people, or it would be forced upon us and things will just sort of happen and fall apart. And that's kind of the choice we have ahead of us.
And on that highly optimistic note, I am thanking you for this conversation, David. Thank you so much. Where can people follow your work? I tried to find your social media, but I realized you're probably too smart to have social media.
I do have
accounts.
some. I don't really use Twitter so much anymore, but I still technically have an account at DVD McKay, on Bluesky, Mastodon. I'm at David A. McKay, and I have a website as well where I sort of I link to various blogs and stuff I write. There's climatetippingpoints.info where I write about some of these issues. My personal website is davidarmstrongmckay.com, or that's more kind of academic. But yeah, you can find me all those places.
You have any sort of books coming up?
Not yet. I have some ideas, but at the moment I'm a new lecturer as of this past year, so I've mostly been focusing on getting all my teaching good, and then I might have some time for some more book writing at some point later.
Awesome. Thanks again for taking the time.
Cool. Thank you for having me.
Thank you very much for listening. Please subscribe to the podcast on YouTube, follow and rate on Spotify and Apple Podcast. Marketing tutorials insist I have to hassle you about that. I hate doing it, but I have to, so I am doing it. Also, if you'd like to, please support me on Patreon. This is a one-person pod, so I do everything by my little old self. There's no team behind me. There's nobody else. It's very sad and lonely, I know, but you can help by hopping on Patreon and finding the Smart Cookies podcast on there. And then last, but certainly not least, I have to thank my existing patrons, Tovarish and Tovarishice. Without you, there would be no Smart Cookies podcast, which makes you actual producers of this show. So eternal thanks goes to the following legends: Bewildered Beauty, Davorin Paulica, Dale and Mia, Chert Kosar, Sasha Sodia, Richard, Amy Ons, Mattia Renchel, Florian Hauer, Peter Karba, Matija Zupancic, Dejan Žolnir, Darej, Rok Tržan, Saša Vipotnik, Neven Cvijanović, Juš Premrov, Sirkezi, Goran Ivašić, Anže Sever, Ole, Marie Ferrara, Aljaš Mahar, Štrole, Aida Mancian, Miha Medet, Medinho, Goran, Gordon, Lorenzo, Jurečuk, Mila, Carmen, Veronica, and Taichi. The list is growing. It's super nice to see. I'm deeply touched. So thanks again, guys. Means a lot.